What we are going to look at now is how to automatically create vectors. For example, if I want to do a plot of sine, and I want an array of numbers from 0 to 2 pi in increments of, say, 100th of a pi, I don't want to go and manually type all those numbers. Is there a way that I could actually create that array of numbers automatically? And actually there are two ways. One of the ways is to use an expression called linspace, Linspace. And the way this works is you would set your variable, and let's say it's x equal. You would type in linspace, and let's just say I want a series of numbers from 1 to 10. And you notice I actually get a little help. I'm going to type 1, comma, 10, parenthesis, and I'm going to hit enter. And you notice what happened is I got not one number or 4 numbers or 10 numbers, but 100 numbers, which started with the first item, which was 1, ended in 10, and I filled in 100 elements in between those two numbers. If I go up to the workspace, I see a variable x. I see it's a value of 1 by 100. The minimum is 1. The maximum is 10. And if I double click, I'm actually going to get a display that shows all those values, which I now can close. If I didn't want to display that, and let's say I wanted to get 100 numbers between 1 and 100, what I can do is say y equals linspace between 1 comma 100, but since I don't want to scroll down, I'm going to put a semicolon. When I hit enter, I don't get anything below that line. But if I look up here in my workspace, I have a variable y that's a 1 by 100 array. It starts at 1 and it goes through 100, and if I double click, I can actually see the numbers 1, 2, 3. So I'm getting 100 numbers between 1 and 100. What if I wanted something a little bit different? Well, I could now type in z equals linspace 1 and 100, but I'm going to type in a third number, 5, and again a semicolon. I'm going to hit enter, and you notice what I get is I get numbers that are oddly distributed, but they're really just 5 different numbers: 1, 25.75, 50.5, 75.25, and 100. So I've gotten 5 elements between 1 and 100. Therefore, what linspace is saying is that start with a number, end with a number, and tell me how many numbers total you want. If you leave that last number off, it will give you 100. Let's clear the screen, and one of the ways of typing is called CLC. You notice we still have the history. You notice we still have the variables. Another way is by using a colon. For example, let me have a variable xx, which is going to be different than x, equals, and I'm just going to do 1 colon 10. If I hit enter, you notice I get 10 numbers, get numbers between 1 and 10 in increments of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if I did xx equals 1 colon 12? I get numbers in increments between 1 and 12. What if I did xx, and you notice every time I'm redefining a function, it writes over it? What if I did 1 colon 12 colon 0.5? I get an error. What if I did x equals 1 colon 0.5 colon 12? Now what I'm getting is I'm getting numbers between 1 and 12, but instead of the default increments of 1, I'm getting increments of half. So using the colon method, it's the beginning, it's the increment, and it's the end. If you want just an increment of 1, you don't have to put anything in between. The colon method is much easier to use, but linspace sometimes can work to your advantage as well, and we'll see later in applications where one may be preferred over the other. The original example, I talked about possibly plotting sine. So I want an array of numbers that go from 0 to 2 pi in increments of, say, 1/100th of a pi. How would I write that? Think about it. What I'm going to do is create a variable called time. I'm going to say that's equal to, and I'm going to say 0 colon. Now remember, the next number is the increment, so in this case I'm going to go 0.01 times, and remember in Matlab, pi is a function. I'm going to go colon, and I'm going to go 2 times pi. I know that's a lot of numbers, so what I'm going to do is type in the semicolon and hit enter. When I go up to time now, right here, I'm glad I didn't print them out because there were 201 numbers. It goes from 0 to 6.28, which is 2 pi. If I open this function, I'm now seeing that I'm actually going in increments of 1/100th of a pi all the way from 0 to 2 pi. That is how you can automatically create vectors.